You know that feeling, right? When you're looking for something, well, better.
Hmm.
Whether it's a new gadget or maybe a smarter way to build something, that curiosity, that pull towards high-performance options, that's kind of what brings us here today.
Absolutely. And today we're diving deep into Superwood. It's a new type of engineered timber.
Yeah, one that's really aiming to shake things up a bit.
Exactly. So think of this deep dive as your shortcut to understanding this pretty fascinating material.
Okay.
Superwood, it comes out of research from the University of Maryland. Now it's being commercialized by a company called Inventwood.
Right, I've heard about them, generating a lot of buzz.
It is, and, for good reason, really.
So what's the core idea behind it?
Well, it seems to be about taking the natural upsides of wood.
Things like sustainability, easy to work with.
Right. And let's face it looks good.
Definitely.
And boosting its performance. Taking it to levels we usually only see with, say, advanced composites or even metals.
Serious strength we're talking. Durability.
That's the claim. Serious strength and durability.
Okay.
And that's really what we're here to explore, isn't it? Our mission, if you like, for this deep dive is to figure out where Superwood actually fits in that whole spectrum of material choices.
So putting it head-to-head with the big players. Fiberglass, carbon fiber.
Kevlar, yeah. And also comparing it against, traditional woods, your cedars, but also those really tough premium hardwoods.
Right, like the tropical ones.
Exactly. We want to cut through the technical jargon.
You're practical.
And understand the real-world implications. What are the advantages? What are the potential downsides for different projects you might be considering?
Okay, sounds good. And we've got some info to guide us.
We do. Two main sources. One is Superwood versus competitors, composites and natural woods. Gives a good side-by-side.
Cool.
And the other is Superwood, properties, uses, and availability. That gets more into the nitty-gritty of what it is and where we might see it.
And you mentioned availability. We'll touch on how easy it is to actually get hold of this stuff.
Yeah, definitely. Because, knowing about a cool material is one thing.
But being able to use it is another.
Precisely.
Yeah.
Okay, so where should we start? High-performance arena.
Let's do it. Superwood versus those advanced composites, fiberglass, Kevlar, carbon fiber. How does it stack up?
Well, it's interesting how they're positioning it. Let's take fiberglass first.
Okay.
Popular stuff. Generally affordable, strong enough for a lot of things. You can mold it easily.
True.
But as our sources highlight, there are environmental questions around the resins used.
Right, the manufacturing.
And it doesn't love long-term UV exposure. Can degrade.
Okay, so that's fiberglass. Where does Superwood come in then?
Well, this is where Superwood plays its green card, so to speak. It's a renewable resource.
From trees, yeah.
And trees absorb CO2 as they grow. That's a big environmental plus right there.
And you still get the wood look, the feel, workability.
Supposedly, yes. Natural wood look and feel. You can work it with standard tools. So, while fiberglass certainly has its place, Superwood seems to be aiming for applications needing maybe a bit higher performance, suggesting it could potentially match or beat fiberglass strength, while being more sustainable. That's the argument. A greener choice with potentially similar or better performance.
Okay, interesting. What about carbon fiber? That's the super high-end stuff, right?
That's the realm of, ultimate strength to weight, incredibly stiff. Think aerospace, high-end racing bikes.
Gotcha.
But that performance, it costs a lot.
Very expensive.
And the manufacturing process takes a lot of energy. Plus, it can be brittle, can shatter on sharp impact.
Right. So how does Superwood compare there? Is it even in the same league?
Well, this seems to be a key selling point for Superwood. The sources say it's much less expensive than carbon fiber.
Much less. Okay.
While still offering potentially comparable strength in quite a few applications, that cost difference alone could be huge.
Yeah, that opens doors.
Again, the sustainability angle. The production is meant to be far less energy intensive.
Makes sense. Okay, one more in this group. Kevlar.
Ah, Kevlar. Known for impact resistance, right? Tensile strength.
Bulletproof vests, ropes, that kind of thing.
Exactly. Incredibly strong in those ways. But, like carbon fiber, it's costly.
And tricky to work with.
Yeah. Not the easiest to cut or shape, apparently.
So the argument for Superwood over Kevlar would be?
Probably hinges on price, first off.
Yeah.
More accessible.
Okay.
And maybe a wider range of uses because it's easier to work, like wood.
And the environmental side again.
And the environmental credentials, the familiarity of working with wood. Imagine getting high-impact resistance in something you can shape like timber.
Okay, stepping back then. Superwood versus these advanced composites. What's the overall pitch?
I'd say three main things stand out. First, Sustainability,
Mm,
renewable resource, potentially smaller footprint.
check.
Second, cost,
Mm,
especially compared to carbon fiber and Kevlar.
right. More accessible.
And third, critically, it keeps the workability and the look, the feel of natural wood, something often lost with synthetics.
And didn't the sources mention something about toughness? Not just strength.
Ah, yes. Good point. It's highlighted as being 10 times tougher than natural wood.
10 times tougher. Wow.
Yeah, think about that. It can absorb significantly more energy before fracturing.
That could be really important where impacts happen, where composites might just crack.
Exactly. That increased toughness could be a real game changer. Okay, so that's the high-tech comparison. But what about wood itself? How does it compare to the stuff we've built with for centuries?
Yeah, like basic cedar or those super dense hardwoods like Purple Heart,
Greenheart.
Greenheart.
Right. And this brings up that cost point again, which is important.
It's not going to be cheap, is it?
Probably not. The sources are pretty clear. Superwood isn't really designed to compete with your everyday low-cost lumber like cedar for, say, basic framing.
Because of the processing involved.
Exactly. It seems to be targeting that higher end. Premium tropical hardwoods, maybe some of the existing engineered wood products.
Okay, so it costs more than standard wood. What's the justification? What's the value?
Superior performance, essentially. Things like much greater strength, better durability.
Fire resistance, too, you mentioned.
Yeah, improved fire resistance. So the idea is that these benefits justify a higher initial price tag compared to even premium natural woods.
And could that higher performance actually save money down the line?
That's part of the pitch, too. Maybe through lighter designs, which means less material overall, or faster construction times, or just reduced maintenance over the building's life.
Okay, let's talk workability again. Traditional wood, carpenters know it inside out.
Absolutely. It's a craft built up over generations.
Yeah.
But natural wood, it has character.
You mean knots, warping, variations.
Exactly. Knots, grain changes, density shifts. These can be challenging, especially if you're doing large-scale work or need high precision. You might waste material or spend extra time working around things.
Right, so engineered materials like Superwood offer more consistency.
That's the goal. Greater uniformity, greater predictability. The sources suggest this means less waste.
That makes sense.
More reliable engineering calculations, maybe faster installation, especially if you're using pre-made parts.
Fewer long-term issues like twisting or warping.
Potentially, yes. Which could mean fewer repairs later on.
So, while a master craftsman might love the uniqueness of natural wood
For sure.
for things like structural beams or maybe components in, I don't know, high-performance gear where tolerances are tight.
That predictability of superwood could be a really big deal. It's about engineering reliability into the wood.
Okay. What about longevity? Durability. We see old timber buildings that have lasted centuries.
We do. But often, that requires pretty specific conditions and ongoing maintenance, right? Protection from moisture, bugs, rot.
True.
Engineered woods, including superwood, are often designed specifically to tackle those vulnerabilities.
Like that polymer-impregnated version you mentioned, M-wood.
Exactly. That M wood is specifically engineered to resist water, fungi, insects.
And the fire rating.
And that Class A fire rating is a major step up in fire safety compared to most untreated woods.
So it might not be aiming for 500 years in a perfect museum setting.
Probably not the primary goal.
But it's designed for reliable, high performance over decades, even in tough conditions, without needing constant babying.
That seems to be the idea.
Yeah.
High performance, reliably, for a long time.
Okay, I think I'm getting a much clearer picture of where Superwood fits. Let's maybe peek under the hood a bit. How is this stuff actually made? What's the science?
Yeah, the process is pretty clever. It starts with regular timber, sustainably sourced. Okay. Then they use a chemical process to remove a good chunk of the lignin.
Lignin, that's the natural glue in wood, holds the fibers together.
Sorta, yeah. It provides rigidity, but it also kind of gets in the way if you want to make the wood denser. It limits how much you can compress it.
Okay, so remove some lignin. Then what?
Then comes intense heat and pressure. This basically compacts the wood's cellular structure, squeezes everything much closer together.
And that's not just physical squashing, is it? Something happens at the molecular level.
Exactly. That compression forces the cellulose fibers, the main strength component, into much closer contact. This dramatically increases the number of hydrogen bonds that can form between those fibers.
And more bonds means more strength.
Way more strength. Those extra bonds are key to superwood's remarkable properties. It's like reorganizing and reinforcing the wood's fundamental structure.
Wow, okay. And sometimes they add polymers, too.
Right, for certain applications, especially where it'll be exposed to moisture or wear, the densified wood can be infused with polymers.
Like sealing it from the inside out.
Kind of, yeah. Adds protection against water, boosts durability even further, so the end result still looks and feels like wood.
But performs way better.
Significantly better performance characteristics, yes.
Okay, lay the numbers on us again. How much stronger or tougher are we talking?
The figures floating around are pretty impressive.
Mm-hmm.
12 to 20 times stronger than the original wood.
12 to 20 times.
Yeah. And about 10 times tougher, as we mentioned.
Okay.
And that strength-to-weight ratio claimed to be up to 10 times better than steel.
10 times steel's strength to weight? That's huge.
It really is. Plus, it's engineered to resist water, fungi, insects, dents, scratches.
And the Class A fire rating.
And the Class A fire rating. Yet it keeps that natural wood grain. You can still stain it or paint it.
Those are some serious specs. So where are we likely to see this stuff showing up first? What are the applications?
Well, the potential uses are pretty broad. Construction is a big one. Residential. Commercial.
Beams, facades, cladding.
Exactly. Could be used for structural elements, exterior finishes, also being looked at for infrastructure, maybe bridges or walkways, interior furnishings, high-traffic flooring, decking. But one area that keeps coming up is marine applications.
Ah, yeah, the boat building potential. You mentioned it competing with aluminum, maybe even titanium. That sounds ambitious.
It does, but when you look at the potential properties...
The strength, mainly.
The strength, yes. It likely surpasses many common aluminum alloys. It could even rival some titanium alloys, especially when you factor in the weight.
Right, it's much lighter.
Reportedly 6 times lighter than steel, and less dense than both aluminum and titanium. So that strength-to-weight ratio becomes really compelling.
Imagine boat hulls lighter and stronger, maybe more fuel efficient.
That's the potential, yeah. Huge efficiency gains possible in transportation.
And compared to metals, you still get the wood look, the feel.
The aesthetics, the tactile quality, yeah. Plus the renewable resource aspect, the carbon sequestration. Metals don't offer that.
Okay. Now, what about comparing it to those legendary boat-building woods? Purple Heart, Greenheart. Those are the traditional benchmarks for toughness in marine use, aren't they?
They really are. They've earned that reputation. Incredible natural durability, density, strength. Greenheart especially is famous for resisting marine borers.
The little critters that eat wooden holes.
Exactly. Those woods are naturally tough. But they can also be really hard to work with because they're so dense.
So how might Superwood actually compare in a marine environment?
Well, direct long-term comparison data is probably still needed. But
based on the claimed strength.
Based on that 12-20 times stronger claim, it suggests Superwood would likely beat both Purple Heart and Greenheart on pure strength metrics.
And being engineered, it would be more consistent. Less variability than natural wood.
Should be, yes. More predictable properties, piece to piece. And it's engineered resistance to water, rot, pests that could potentially match or even exceed these hardwoods for general longevity.
Though maybe not the specific marine borer resistance of Greenheart.
That's a very specific, very high bar Greenheart sets naturally. We'd need more data on M-Wood's performance there. But Superwood might offer easier, more predictable workability.
Better dimensional stability, perhaps. Less warping.
Potentially.
Right.
And a really big point here, sustainability.
Compared to tropical hardwoods.
Exactly. Many of those premium tropical species are threatened or come from questionable logging practices. Superwood aims for a clear advantage there, using sustainably sourced timber.
Okay, this paints a really promising picture. It sounds like a fantastic material. But the big question for anyone listening who's excited now...
Can I buy it?
Yeah. When can people actually get their hands on it? Availability, let's talk about that.
Right. Crucial question.
Okay.
As of today, and we're recording this, May 23rd, 2025, Superwood is basically on the verge of its commercial launch.
Okay, close, huh?
Initial shipments are expected Q3 this year, so later in 2025.
But not yet generally available. Like, I can't order some today.
Not quite yet for general purchase, no. Especially not specific stock sizes or that polymer-infused M-Wood version we talked about.
But one you'd want for marine use or decking.
Exactly. Those more demanding uses.
So what is coming first, then?
The initial focus from their factory in Frederick, Maryland, seems to be on facade materials.
Ah, architectural stuff.
Yeah, panels, boards, things for exterior cladding, aesthetic finishes on commercial buildings, maybe high-end homes.
Gotcha. What about structural sizes, like 2x4s or beams made of superwood?
Good question. Right now, there isn't much public info on standard stock sizes or shapes like dimensional lumber. It's likely those details will come out closer to the actual launch. Inventwood has talked about future plans for structural uses.
Using wood chips, maybe? For different sizes?
Potentially, yeah.
Yeah.
Using different feedstocks for more variety.
Yeah.
But that sounds like it's further down the road, not in this initial rollout.
Okay. And what about that M-wood? The polymer version for tough applications, marine craft components, things like that.
So while M-wood and its properties have definitely been developed and highlighted, its immediate availability is tied to that overall Q3 launch timeframe. We don't know for sure if it'll be in the very first wave of products.
And probably not targeted for really niche uses straight away. Like, say, someone wanted to build a whitewater kayak out of it. Or a motor mount.
Unlikely. It seems pretty clear the initial market push is architectural and construction.
Yeah.
Those niche high-demand uses will likely come later once production scales up and more testing is done.
Right. So for a listener who's really intrigued, maybe especially by M-wood, for something demanding, what should they do?
Best bet right now, keep an eye on Inventwood's official website. Follow their announcements as we get closer to Q3 2025.
Okay.
Once shipments actually start, the best thing would be to contact Inventwood directly or their North American distributor, which is a company called Intextural.
Ask them about M-wood specifically.
Yeah, ask about M-wood availability, get the latest specs, find out what dimensions they're actually offering, and discuss if it's suitable for your specific application, like marine use. They'll have the real-time info.
Okay, that makes sense. Patience, then check directly later this year. All right, let's wrap this deep dive up. Key takeaways. What should people remember about Superwood?
I think the main thing is that Superwood is a really exciting development. It's trying to bridge that gap, between traditional wood and those high-performance composites and metals.
Best of both worlds, potentially.
That's the aim, a unique mix of boosted strength, sustainability, and still keeping that workability of wood.
But not a magic bullet for everything?
No, definitely not positioned as a direct swap for every material out there. But its specific properties make it a really strong contender for certain demanding jobs.
Especially where you need that high strength to weight. Durability. And the environmental angle matter.
Exactly. Those seem to be the sweet spots.
And it sounds like we're just at the beginning. As it hits the market, we'll learn a lot more from real-world projects.
Absolutely. More data, more examples that will really clarify its role and maybe even uncover uses we haven't thought of yet.
Definitely feels like just the start of its story.
For sure.
So here's a final thought for you to chew on. Just imagine the possibilities if a truly high-performance, sustainable, and workable wood-based material like this becomes widely available. Think about it across industries, construction, transport, even consumer goods. What new designs, what new solutions might pop up once a material like Superwood is just there. A mainstream option. It's definitely something worth pondering.